One last practice problem with the Poisson. It says approximately 10% of the population is left-handed. In a room of 200 people, find the probability that exactly 12 people in the room are left-handed. Round to 3 decimal places. Okay, let's check it out. We'll use the Poisson here. Okay, so let's think. First thing we need to do, you might have seen that. First thing we need to do is define what a success is in this case. And I think the natural reading of that problem is to say, okay, we're looking at exactly 12 people left-handed. Let's say a success is being left-handed. Okay. And now let's try to figure out what the unit for the Poisson represents. What is the unit here? And I got to tell you, in this one, it's not so obvious. Right? It's not a unit of time, right? That's not a part of this problem. So if you go back to the definition of the Poisson, it says the unit is typically a time interval. Well, that's not the case here, but it could be any type of unit where multiple successes can occur. So we have a room of 200 people. We want the probability that exactly 12 are left-handed. What is the unit? And sometimes people will say, students, when I'm teaching, they'll say, well, it's each person. Each person is a unit. And that wouldn't not be the case, because a unit is where multiple successes can occur. And if you're talking if each person is a unit, then there's only one possible success. But a unit has to be where multiple successes can occur. But oftentimes there's at least one or two people in the room who spot it. In this case, the unit is the entire room. In a room of 200 people, or you might even say it's all of those people. All the 200 people make up one unit. All 200 people. Okay. So that's tricky here. Okay, so then what is lambda? That's really what we're after. We want to calculate lambda using this unit. Well, in this case, we're going to use the second style talked about earlier. We're going to think of lambda as the expected number of successes per unit. Okay, so if the unit is the entire room, how many successes, how many left-handed people would we expect? You think, well, expect, that's like expected value. It's kind of like we're finding an average, right? So there's 200 people. We also know the percentage of the population. So that's how we're going to do it here. It looks like I mentioned X already, but okay, lambda is going to be all 200 people in the room times 10% would give you 20. So in a room of 200, we would expect there to be 20 people that are left-handed, right? 10% of 200. So that's our lambda here. And then X equals 12, well, because we are trying to calculate exactly 12 people in the room, exactly 12 successes, exactly 12 people left-handed. Okay. And this is really the hard part, identifying the room, getting the lambda, identifying even, X being 12. Once you have all that, then you can just put it right on into the formula. The probability of 12, here it's e raised to the negative 20, 20 raised to the 12 over 12 factorial, plugging all those in. And here, there's no hope for simplifying any of that. Just put it all into your calculator. And if you have a factorial button, then that's a good time to take advantage of it. But even if you don't have that factorial button, 12 factorial It's not the end of the world. You can do 12 times 11 times 10 all the way down to 1. Be sure you get the same answer that I got to 3 decimal places. It was 0.018. And if you're wondering what that represents, what did I write here? People left-handed. No. It's a probability. What was I thinking? The shadows are getting in my head too. Okay. It's 12 left-handed people. That's a probability. 0.018 chance. 0.018 chance, less than 2% chance that there are 12 people left-handed in that room, which seems very, 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 very small, right? You think, there's probably a pretty good chance that there's well, we would expect there to be 20 people. So 12 is very far from 20, right? So the chances of there being 12 are really small because it's so far away from what we'd expect. Okay, that is the end of the Poisson. That is the end of chapter 4. Go check out the homework.